Okay, so here's example 3. There's 3 parts, A, B, and C. Let's focus on A first. The instructions say use rules of exponents to simplify each expression. Okay, so in this case, we're not as focused on evaluating, okay, and we're more focused on just simplifying the expression. If we can evaluate, we will. But really the point of this example is to see if you can apply your rules of exponents when you have fraction exponents. All right, now part A gives you 25 to the 5/6 times 25 to the negative 1/3. What's the rule here? Well, you have like bases being multiplied. When you multiply like bases, you're supposed to add the exponents. So 25 to the 5/6 times 25 to the negative 1/3 becomes 25 to the 5/6 plus negative 1/3. Now I have a totally separate problem to deal with. I have to add these two fractions. Okay, so let me go off to the side and add 5/6 and negative 1/3. So there's my work for adding 5/6 and negative 1/3. I need a common denominator, which is 6. So I multiply the second fraction here by 2 over 2. Combine the numerators, and then in the end I have to reduce it. So this 1/2 is what's going to go in for this expression here. Which means altogether, 25 to the 5/6 plus negative 1/3 is going to end up being 25 to the 1/2. And in this case, because I have a whole number base here, or a constant base, I can actually evaluate this by taking the square root of 25. That's what the 1/2 power means. Square root of 25 is 5. So that's what 25 to the 5/6 times 25 to the negative 1/3 simplifies to. Alright, so part B is more of the same. Okay, we have an expression with fraction exponents, and we're going to use our rules of exponents to simplify. Alright. So if you look at the expression, first I would go ahead and simplify the denominator because you have a multiplication of like bases, which means again we have to add exponents. So the denominator in this expression is going to become y to the negative 1/2 plus 3/4. Okay, so my new exponent is the sum of these two fractions. The numerator I haven't touched yet. We'll come back to that later. But for right now, let me go ahead and do this addition problem. I have negative 1/2 plus 3/4 that I need to simplify so I can make this a single exponent. So if you actually calculate negative 1/2 plus 3/4, you get a common denominator of 4, and you end up with 1/4 in the end. So that's what I'm going to put back in here for this exponent, which makes my expression y to the 1/8, which I haven't done anything with yet, divided by y, and then I'm going to put my exponent of 1/4. Okay. Now, I have a division problem. I'm dividing like bases. The rule says when you divide like bases, you should subtract the exponents. So altogether here, I'm going to end up with y to the 1/8, right? When you apply the quotient rule, do top minus bottom, 1/8 minus 1/4. And now I have another subtraction or addition problem to deal with here. So let me go to the side and calculate this subtraction problem. 1/8 minus 1/4, the common denominator is 8. When you finish the subtraction, you get negative 1/8, which means altogether here I have y to the negative 1/8. Okay. One final simplification, we never leave negative exponents in our result, so we have to flip to get rid of the negative exponent and make this 1 over y to the 1/8. Okay, so that'll be our final result. All right. There's no need to change this into an 1/8 root, okay, because this base is a variable. We won't be able to calculate the 1/8 root of y anyway. So this is really the best we can do. So in part C, we have a new expression, and we're going to use our exponent rules to simplify it. Okay. Now, we threw in a subtraction here. So we have a multiplication of z to the 3/5 by z to the 1/2 minus 3z to the 3/4. So because we're multiplying across a minus sign, we have to distribute the multiplication. Okay. Which is going to give us z to the 3/5 times z to the 1/2. And then in the second case, we have this -3 constant that we're going to leave out front, and then we'll get z to the 3/5 times z to the 3/4. So after we distribute, this is our expression. Now at this point, we are once again multiplying like bases. Okay, when you multiply like bases, the rule says you add the exponents. So for the first term in this expression, we are going to end up with z to the 3/5 plus 1/2. So we have to add those exponents. Minus 3 times z to the, again, add these exponents, 3/5 plus 3/4. And then each one of these is a separate addition problem that you have to deal with. We have to do 3/5 plus 1/2, and we have to do 3/5 plus 3/4. So I'll take both of these aside and calculate them separately. So there's my work for the addition problems. 3/5 plus 1/2 ends up giving you 6/10 plus 5/10, which is 11/10. Then on the other side, 3/5 plus 3/4 ends up giving you 12/20 plus 15/20, which is 27/20. So altogether here, my problem, or my expression, ends up looking like z to the 11/10 minus 3z to the 27/20. Okay, there are no exponent rules for subtraction. Okay, we cannot subtract these two terms because they're not like terms. They have different exponents. So at this point, there's really nothing more we can do. So this is our final answer.